Alright, this is about removable discontinuities, or what we call holes, in rational functions. So we've already talked about how to find a vertical asymptote, and you can find that vertical asymptote just by taking the denominator, factoring it if necessary, and setting the pieces equal to 0. You need to figure out what the denominator cannot be, because of course you can't divide by 0, so you don't want that bottom to go to 0. Well, usually values of x that make a denominator 0 create vertical asymptotes, like we discussed. There's an exception though. If that value makes the numerator 0 also, then this creates what we call removable discontinuity. That's kind of long and hard to write and even sometimes a little difficult to say. So we'll call it either RD or we'll refer to them as holes. Now the way that you recognize a hole, you have to first, because if you were to plug this in your calculator and look for the error message, the table is going to say error whether it is a hole or a vertical asymptote. So you have to be able to tell the difference. So in order to know for sure, you have to factor. So factoring again with our rational expressions is hugely important. So if you look at this example here, we've got x squared minus 3x over x squared minus 2x minus 3. We're going to factor that. We factor the top with a GCF of x, and you get x and x minus 3. And then I'm going to factor the bottom trinomial. It factors as two binomials, x minus 3, x plus 1, which we factor here. And when we're looking for the RD, we recognize the piece that is the same on top and on bottom. And in this case, it's the x minus 3. This is where the hole in the graph is going to occur. So x minus 3 equals 0. So x equals 3 is where the hole occurs. And you can see here on the graph, that's where our hole is. That is our removable discontinuity. It's like a piece of the line has just been removed. So it creates a hole in the graph. What's left in the denominator is still a vertical asymptote. So I have a vertical asymptote at -1. And you can see that on the graph here as well. So let's jump down and do a problem. Here's my problem, and the first thing I'm going to have to do is factor. So I'm going to factor my top as x plus 4, x plus 2. Factor the bottom as x minus 3, x plus 2. Now, the easiest thing to identify here is my removable discontinuity. So I'm looking for the place where these two, the numerator and denominator, are the same. And that will be right here. So x plus 2 equals 0. So x equals -2. That's where my hole is going to occur. That is my RD. Because both the numerator and the denominator would become 0 there. Which means that the piece left over is my vertical asymptote. And this is asking me also for my HA, or my horizontal asymptote. So remember, we find that by comparing degrees. The degrees here are the same. I have a squared over squared, which means that you use the coefficients. So y equals 1. And that's how you find removable discontinuity, or holes.